हरि करना।
Now let's see some of the basic rules of probabilities for the random variables, random variable distribution. So in probability theory, the following rules are important for manipulating and computing probabilities of random variables. Out of them, sum rule, multiplication rule, Bayes theorem, and chain rule. So we'll begin with sum rule. Sum rule. The sum rule states that the probability of a certain event occurring can be found by summing up the probabilities of all possible ways in which that event can occur for a discrete random variable x. For a discrete random variable x, capital X, the sum rule can be expressed as sigma of y p of capital X comma capital Y, summation of the summing up the probabilities of all possible ways in which that event can occur is your sum rule. And similarly for continuous random variable, in spite of using summation, of course it's continuous, so you have to take up the interval and then you have to take up the density. So that's the reason we have to calculate the area it spreaded. So for that we'll use integration. Integral p of capital X comma capital Y or of dy, integration of p of x comma y dy. So this is how we calculate. Okay, so let me write down the equation for a discrete, and then let's take one example. So this one for us is sum rule. Sum rule. So this is how we show p of x is equals to small x is equal to, I want to put in summation, I'll put, this is the symbol, summation symbol, summation of p of x is equals to x comma y is equals to y. And anyway, you can see this, you can see the equation from our slide itself. Yep, for discrete. Okay, now let's take one example. However, in this equation, y is another random variable. In other words, the probability of capital X is equals to small x is the sum of the joint probabilities of capital X is equals to x and capital Y is equals to y over all possible values of y. Again, I'm repeating this here. So this means, this equation means for discrete, the probability of capital X, the probability of random variable x is the sum of the joint probabilities of x random variable, y random variable for over all possible values of y, over all possible values of y. Now it's time for example. So example in computer vision, we'll take an example from computer vision. Suppose we have a binary classification where x is a binary random variable representing whether an image contains a cat or not, whether an image contains a cat or not, and y is equal to another binary random variable, and uh, this represents whether an image contains dog or not. So the sum rule can be used to compute the probability of an image containing a cat by summing the probabilities of all possible ways in which the image can contain a cat, that is with or without a dog. So we can put it capital X P of X, that is equals to 1. That's our cat, is equals to P of capital X is equals to 1, and capital, this is our first joint probability, and plus it could be sick now. X is equals to 2, X is equals to 1, and Y is equals to 0. That's it. That's the best example, simple example for this.